Hi everyone, today we're going to start our investigation on bridges. We're primarily going to look at a very simplified version of bridge, basically a beam supported on two ends. So if you're unfamiliar with the terms, we have long members, horizontal ones are called beams, and vertical ones are called columns. So if you're unfamiliar with the terminology, so that's how they classify it. So a bridge, at least the surface part of the bridge is acts as a beam because it's horizontal and it's mostly supporting downward loads. So here is a very simple model. If you look at two ends, it's a very typical in analyzing beams. So you have a pinned end. So basically it's a pin, which means that the pin here can resist both horizontal and vertical forces. So the pin here will stop the beam from shifting left or right or up and down. However, because it's pinned, so it cannot support against any moment. So if the beam is going to suddenly rotate for whatever reason, there's nothing to stop it from doing so. And the other end is a roller support, which means it can only provide a reaction against the vertical forces. It can only stop this end from moving up or down. It cannot stop left or right movement, nor can it support against moment. So let's say a force is applied on this a beam. Now, if this beam stays completely stationary, if it doesn't move up or down, left or right, or it doesn't suddenly start spinning, it means that all the forces and the moments in the system will be in a state of equilibrium. They will all cancel each other out. So now let's look at the sum of the forces then. So let's say let's label these reactions. So firstly, let's look at vertical. In the vertical direction, this beam is not moving up or down, which means these two reactions would be canceling out the downward force. So let's label them. So let's call this, because it's the first point, so let's call this point A, this end B, so which means AY, AX, and BY. Okay, what does this mean? It means this sum of the forces in the x direction has to equal to 0. Yeah, which means let's call this just load. Let's just call it force. Yeah, so this is the downward force. Now it means F, yeah, has to equal to AY plus BY. They have to be equal and opposite. Otherwise, the beam will either start moving downwards or upwards. Yeah. And of course, if we can say that these two has to cancel this one, then the downward force will have to equal the sum of the reactions on the two ends. Yeah. And of course, there is really no horizontal force. Yeah. Sorry, it should be Y. My bad. Yeah. So and there is no horizontal force. So that means it's in a state of equilibrium horizontally, which means the AX has to also equal to 0. Yep. Now, this is the horizontal and vertical forces. Now, what about the moment? What we can do is we look at the moment at so let's look at the moment at A. Yeah, so sum of the moment at A has to equal to 0 as well. Otherwise, the whole beam will start spinning. Now, that means what gives us moment. So let's just say the force being loaded is right in the middle of the beam. So this is L. This is L over 2. This is L over 2. Yeah, that means the force times L over 2 will generate. So F, this force acting on this arm, will rotate the whole thing in a clockwise direction. Yeah. Sorry. F times L over 2 has to rotate in so the reason the beam is not actually rotating in a clockwise direction is because the moment generated by this force, the vertical force By here, because as you can see just from the diagram, By times length L is trying to rotate the beam counterclockwise. Yeah. So there's a counterclockwise moment generated by By times L, and a clockwise moment generated by F times L over 2, which is turning in opposite directions. So they cancel out, and that keeps the beam stationary. Yep. So F times L over 2 has to equal to By times L. Yeah. So this is the state of equilibrium of the beam. Of course, because F is acting right through the middle of the beam, we can easily just say AY and BY will be equal to each other. You just half F on each end. So this is pretty simple, and then everything else everything cancels out. Now things get slightly trickier if we have a very similar beam, but the force acts through not through the center. Let's say it's acting through here. Yeah. Let's say there's a force of 10 kilonewtons. Yeah. And then let's say the beam is let's say 3 meters this way, and 1 meter. Yeah, it's a very short bridge. So this is what we have here. Now we're trying to figure out the reactions on the two ends that will have to be different, because just by experience you'll know that the support on the heavy on the end the load is closer to will bear the larger portion of the load. So obviously we still have our forces. So AY, AX, even though once again, because the force is acting vertically downwards, we probably don't have to worry about horizontal reaction. And of course, we also have BY here. Now, so BY, obviously from experience, will be a bit larger than AY. And now we want to calculate exactly what the values of them are. So we're going to use exactly the same process as we did earlier. So let's say the sum of the forces. Yeah, so the sum of the forces in the will have to be 0, because there is actually no horizontal forces. So we don't have to worry about it. Now, what about vertical forces? Well, if vertical forces, all the forces in the vertical direction have to add up to 0, then it means that 10 kilonewtons equals to AY plus BY. But that does not give us enough information, because there's infinitely different combination of A and the B, AY and the BY that will make this equation work. So what we need is we need to find out one of them, which we can do with the application of moment, because notice that 10 kilonewton here times 3 is creating a clockwise moment, and it needs to be cancelled out by a counterclockwise moment produced by By times the whole length. Okay? So for the moment the sum of the moment at A. So once again, because it's a pivot, the thing can rotate. Can equal to By, so it has to equal to 0, which means the moment of 10 kilonewtons times 3 meters has to equal to By times 4 meters. Yeah, which means By equals to, it's 30 over 4, which equals to 7.5 kilonewtons. Yeah. And then what we can do now is we can go back to A. So we know that AY plus BY. So it goes back here. AY plus BY equals to 10 kilonewtons. So, and BY, because we know BY is 7.5, which means AY equals to 2.5 kilonewtons. And so there is that.